Good morning, students. Today we are going to learn new chapter, chapter 10, differential calculus. So, first of all, let us understand what is the meaning of differentiation. So, differentiation is nothing but a rate of change. Rate of change. It means that if you are changing a quantity with respect to another quantity, to understand better, for example, let us take a circle of radius 3 centimeters. So area will be something around 556 centimeters square, let us suppose. So if I am increasing my area, radius of the circle up to 4, so what happens to my, if I am increasing my radius of the circle, what will happen to my area of the circle? So this rate of change means if I am increasing and changing the radius of the circle, then what will happen? What will be the impact on the area of the circle? So that comes under rate of change. But in this chapter we are going to discuss at instant. At a particular instant only we are going to check. Okay. For understanding better, let us look at this example. Let us suppose from A to B we are making a journey with 50 km per hour we are traveling. Let us suppose average speed is 50 km per hour. So it is taking for our 3 hours to complete the journey. So the question is, after 2 hours, what is the speed? What is the speed of the bus? So I am asking at 2 hours. So at instant I am asking, then I have to use differentiability. So this is where we are going to use the differentiability concept. So differentiability is nothing but rate of change of a particular quantity with respect to change in another quantity. So rate of change of one quantity with respect to another quantity. So first let us learn what is the concept of derivative. So this can be discussed on major 4 issues. There is tangent line, tangent slope problems, and the second one is maximum minimum problems. Maximum and minimum problems. The third one is area problems. Velocity and acceleration problems. Velocity and acceleration problems. So in this chapter we will focus on tangent slope problems, and in the later coming chapters we will get a detailed value of this maximum, minimum problems, area problems, and all these problems. So let us discuss what is tangent slope problem. So for this understanding purpose, let us take a curve here. So this is the curve. So this is x-axis, this is y-axis. I am assuming this point is x0. And I am assuming the other point is x0 plus h, the other values, okay. So this point will become, let it be A, let it be B. So the point B is x coordinate comma y coordinate, I can write it as x0 plus h comma function of x0 plus h, y coordinate, okay. Here I can write it as x0 comma f of x0, x0 comma f of x0. So we have learned that slope of a line, so which is nothing but secant, which we can give the formula as m secant as y2 minus y1 by x2 minus x1. So difference of their y coordinates by difference of their x coordinates. So difference of the y coordinates is y2 minus y1, that I can write it as f of x0 plus h minus f of x0 divided by x2 minus x1, that is x0 plus h minus x0. x0 gets cancelled. So the formula is x0 plus h minus f of x0 divided by h. So this secant, we can write it as tangent as well. Why we can write it as tangent means, see, for understanding purpose, in this concept actually why we are making it as a tangent slope. Why we are writing it as m tangent slope? Look at here. For example, let us take a balloon. And on the balloon, if we are drawing a line, so obviously this will become a secant. So let us blast the balloon. If you blast the balloon, what will happen to this point? This point will remove and it will be touched to the tangent. It means that the secant line is totally wrapping up and it is becoming a single point. So it means that secant is becoming tangent only in terms of this curves concept. So that's why I am mentioning this formula for m tangent. So slope of the tangent is f of x naught plus h minus f of x naught divided by h. So if I apply limits here, limit h tends to 0, f of x naught plus h minus f of x naught divided by h is equal to slope of tangent. Next, let us see the derivative definition here. Let f be a open interval function containing the point x naught. So in that function x naught is the point. Suppose that if limit is going to exist, that the slope of the tangent if it is going to exist, then f is said to be differentiable at x equals to x naught. Then we are going to denote by f dash of x naught. We have to denote this as f dash. F dash of x naught is equals to limit h tends to 0, changing the y value by h. So that is what limit h tends to 0, f of x naught plus h minus f of x naught by h. So this is the derivative formula. So this way we can call it as a first principle also. Derivative by using the first principle. Now, let us understand about left hand derivative. And right hand derivative. Right hand derivative. So the meaning of left hand derivative and right hand derivative. First, let us write the derivative definition. F dash of x is equal to limit h tends to 0, f of x naught plus h minus f of x naught divided by h. So if I am targeting about left hand derivative, then the formula will become f dash of x minus left hand derivative is equal to limit h tends to 0 minus f of x naught plus h minus f of x naught divided by h. Next, if I want a right hand derivative, x plus, that is limit x tends to 0 plus f of x naught plus h minus f of x naught divided by h. So these are the left hand derivative, this is right hand derivative. So here, if left hand derivative is equal to right hand derivative, then we can see that the function is differentiable. The function is differentiable. So previously we have seen about continuity. So in continuity, left hand limit, right hand limit and functional value should be equal. So in order to make a function as a derivative or differentiable, so left hand derivative and right hand derivative values must be equal. Then only we can do the derivative. So the first question, let us see exercise 10.1 first question. Find the derivative of the function by using the first principle. So already we have the first principle. So if given a function, let us write the first of x is equal to limit h tends to 0 f of x naught plus h, or else we can write x plus h minus f of x divided by h. So this will be the derivative of the first principle. So we need to find out first f of x plus h value, then minus f of x we have to do. So limit h tends to 0 f of x plus h, it means minus 4 in place of x we have to put x plus h. X plus h plus 7. So next minus f of x value, let us put in bracket minus 4x plus 7 divided by h. So in place of x I am substituting x plus h. Let me limit h tends to 0, it will become minus 4x minus 4h plus 7 plus 4x minus 7 divided by h. So plus 7 minus 1 plus 4x minus 4x gets cancelled. So we are left with limit h tends to 0 minus 4h divided by h. H gets cancelled. So the answer we are getting is minus 4. Okay, next let us do the third question of the same bit. F of x is equal to minus x square plus 2. So same by using the first principle. So let us see the answer. F dash of x is equal to limit h tends to 0 f of x plus h minus f of x divided by h. So limit h tends to 0 f of x plus h. So it is minus of x plus h whole square plus 2 minus x square plus 2 divided by h. So wherever you see x, you have to put x plus h. So the next is limit h tends to 0. It is in the format of a plus b whole square. So a square plus 2ab plus b square plus 2 plus x square minus 2 divided by h. Limit h tends to 0. If I open the bracket, it will be minus x square minus 2hx minus h square plus 2 minus 2 gets cancelled plus x square divided by h. So minus x square plus x square gets cancelled. So that is limit h tends to 0 minus 2hx minus h square by x. So I can take h common in this numerator. If I take h common, so it is left with minus 2x minus h divided by h. H gets cancelled. So if I apply the limit, so I am left with this will become 0. So the answer will be minus 2x. Let us see the second question. Find the derivatives from left and right. So we need to find out the left hand derivative and right hand derivative at x equals to 1. If they are existing, we need to say whether the function is differentiable or not. Let us see. He has given some modulus function, so that modulus function will replace it. If it is less than 0, x is less than 0, negative value, so it will be minus multiplied minus x plus 1. If x less than 0. If x is greater than or equal to 0, so it will be normal modulus x minus 1. So this condition we will use. So first let us find the left hand derivative. Left hand derivative. So which is f dash of 1 minus, since we are finding it 1, so we are using 1, is equal to f of x plus h minus f of 1, so f of x minus f of x minus f of 1 divided by the given function x minus 1. That equals to f of x, what we have to use here 1 minus, so it means that less than 1. So let me apply the limit x tends to 1 minus. So I need to use the function which is less than 1. Less than 1 means I will use this. So it will become limit x tends to 1 minus minus x plus 1. So if I substitute 1 in the given function, 1 minus 1 will be 0 divided by x minus 1. So I can take this minus common. So if I take minus common, the answer will be limit x tends to 1 minus of x minus 1 divided by x minus 1. Gets cancelled. So the left hand limit I got it as minus 1. Next, let me find out right hand limit. So right hand, not limit, derivative. Right hand derivative. So that is f dash of 1 plus. So this can be written as limit x tends to 1 plus f of x minus f of 1 divided by x minus 1. So that is 1 plus. So we can use limit x tends to 1 plus more than 1 is x minus 1, here minus 0 divided by x minus 1. So x minus 1 gets cancelled. So the answer will be 1. So here we got left hand derivative as minus 1 and right hand derivative as plus 1. Since left hand derivative value is not equal to right hand derivative value, therefore the function is not differentiable. The function is not differentiable at x is equal to 1. In the same way, we are doing a third question. So whether it is asking at 1, whether the function is differentiable at 1. So let us find out first left hand derivative, that is f dash of x. So f dash of 1 minus, already by value f dash of 1 minus. So limit x tends to 1 minus f of x minus f of 1 divided by x minus 1. So limit x tends to 1 minus, so the function which is less than 1 is x only, x minus, if I substitute 1, it will be 1 divided by x minus 1. So x minus 1 gets cancelled. I got the left hand derivative as 1. Next, let me stick with right hand derivative. So if I do right hand derivative, that is f dash of 1 plus. So that can be given as limit x tends to 1 plus f of x minus f of 1 divided by x minus 1. So here I need to take more than 1. So it will be limit x tends to 1 plus x square minus f of 1 divided by x minus 1. So it is in the format of x square minus b square, so I can write it as limit x tends to 1 plus x minus 1 into x plus 1 divided by x minus 1. So x minus 1 gets cancelled. If I substitute 1, the answer is 2. So previously I got left hand derivative as 1. Left hand derivative I got it as 1. Right hand derivative I got it as 2. So left hand derivative is not equal to right hand derivative. Therefore the function is not differentiable. Function is not differentiable at x is equal to 1. Let us see the third question. Determine whether the following function is differentiable at indicated value. So here there is some function x modulus x at x equals to 0. So this can be changed to, if x is less than 0, so it will be negative. So my x into minus x, it will be minus 65. If x is greater than or equal to 0, greater than 0, x modulus x will be normal x. So x into x will be x square. So let us start finding. So it is asking differentiable at x equals to 0. So we will find out the left hand derivative and right hand derivative. If both are equal, then we can say that it is differentiable at x equals to 0. So let us see the answer, solution. So left hand derivative first. F dash of 0 minus left hand derivative is equal to limit tends to 0 minus f of x minus f of 0 divided by x minus 0. So limit x tends to 0 minus f of x. So we are taking less than 0, so it will be minus x square minus f of 0 is substitute 0, it will be 0 divided by x. So if I substitute 0, so it will be, we are left with limit x tends to 0 minus x square by x gets cancelled. So limit value is minus x, that is minus 0, which we can write it as 0. So we got the left hand derivative as 0. So let us find out the right hand derivative as well. So if we are talking about the right hand derivative, f dash of 0 plus. So this is limit x tends to 0 plus f of x minus f of 0 divided by x minus 0. Since we are taking more than 0, so here it is more than 0 function, so we have to take it as x square. So limit x tends to 0 plus, here we can write it as x square minus, if I substitute 0 in the function value, it will be 0 square, which is 0 divided by x. So limit x tends to 0 plus x square by x, which is x. If I substitute 0, so the function value is 0. Since left hand derivative is also 0, right hand derivative is also 0. So we got left hand derivative value is 0 and right hand derivative value also 0. So it means that left hand derivative is equal to right hand derivative. Therefore, the function is differentiable at x is equal to 0. Let us see the fourth question. Show that the functions are not differentiable. So we need to show that whether the function is differentiable or not. Answer. Let us find the left hand derivative. So here is asking at the point 2. F dash of 2 plus, sorry, 2 minus left hand derivative. That is limit x tends to 2 minus f of x minus f of 2 divided by x minus 2. So f of x less than 2 means we need to take this function. So limit x tends to 2 minus f of x value is minus x plus 2 minus, if I substitute 2 in this, it will be 0 divided by x minus 2. So I can take minus common in this, it will be limit x tends to 2 minus if I take common x minus 2 divided by x minus 2. So answer is minus 1. So I got the left hand derivative as minus 1. Now let me check its right hand derivative. So right hand derivative f dash of 2 plus. So limit x tends to 2 plus f of x minus f of 2 divided by x minus 2. So these two values. So limit 2 plus means more than 2. More than 2 means I need to take 2x minus 4 function. So 2x minus 4 minus, if I substitute 2 value, it will be 0 divided by x minus 2. So limit x tends to 2 plus, I can take 2 common, so 2 into x minus 2 divided by x minus 2. X minus 2, x minus 2 gets cancelled. So the answer I got it as 2. So I got left hand derivative as minus 1 and right hand derivative as 2. Since left hand derivative is not equal to right hand derivative, therefore the function is not differentiable. The function is not differentiable at x is equal to